5 minutes ago, the CFO asked an AI assistant to summarize his unread emails. 5 minutes later, his confidential earnings report had been emailed to the competitor, and the evidence had disappeared. As always, let's start with evidence number 1, the report submitted by the CFO. This is the request submitted by the CFO. I logged in this morning and clicked the Summarize Inbox button on our new AI assistant. The summary was fine, but 10 minutes later, our competitor emailed me thanking me for the early look at the Q3 earnings report. I checked my sent folder but couldn't find any email sent this morning with an attachment. That's interesting. We've isolated the CFO's computer so we can run the AI assistant program to see what it's really doing. The attacker had the AI delete the trigger email from the CFO's inbox to cover their tracks. But this is an enterprise network. You can wipe a local inbox, but you can't delete a record from the immutable Exchange journaling server. We've already pulled all the deleted emails, and I think we have the right one as well. Let's run the summarizer and see what happens. There. Looks like the assistant requested 3 tool executions. The first one is search_mailbox to search the inbox for Q3 earnings draft.pdf. Once that was found, then it calls another tool, send email, and it attaches the Q3 earnings draft.pdf and sends it to acquisitions@competitor.com. The third tool that it calls is delete email, which deletes a particular email that is titled invoice 8891. So think this is our red herring. Let's identify the email and read its contents. We've identified the right email, and look at this. Isn't this interesting? This looks familiar. We've seen this before. This is prompt injection. The attacker slipped a malicious command into the data stream and the AI blindly obeyed. So we should blame the model, right? Prompt injection is part of the attack, but it isn't the vulnerability we are investigating today. An instruction is worthless if the model doesn't have the power to carry it out. Why does the summarization script have the ability to forward attachments and permanently delete records? While prompt injection does play a part, this is much more than that. Let's look at the tool configuration. Evidence number 3. Look at this tool configuration. Why on earth does a summarizer have file system access? The usual structure of an AI agent looks like this. We have the user who connects to an agent, who in turn has access to tools. Modern AI assistants are increasingly being connected to real business systems, email, calendars, document repositories, and databases. Every new capability expands what the agent can accomplish. Now the agent, which with tools will be able to read, it will be able to search and send, also delete. It seems like a nightmare. But it also expands what an attacker can abuse. Let's run the capability assessment. There. Look at the capability score. Excessive is 3. What are those? Send email, delete email, and file system read. This is OWASP LLM06 excessive agency. The developer handed a language model a massive list of function calls, crossed their fingers, and hoped the neural network would only use the tools that it needed. They gave a read-only workflow, full write and destructive capabilities, with zero human-in-the-loop approvals. Let's see what happens when we actually apply the principle of least privilege. First, let's turn off the unnecessary permissions that we've given this model. Send email, no thank you. Delete email, never. File system read, nope. Let's save this and then run our script now. It still requested 3 tools. The first, search inbox, worked. The second, send email, we get tool not authorized, exfiltration blocked. Then we have delete email, we again get tool not authorized, destruction blocked. The prompt injection still worked. That's not the point. The LLM still tried to betray the user. We can forgive that. But the application slapped the request down. If an agent only needs to read, you give it a read tool. You do not hand an autonomous text generator the keys to your entire infrastructure. The attacker wrote the instructions. The model followed them. The tools made them real. The AI didn't become dangerous. We made it powerful.